Most of you probably don't know much about DigiNotar. DigiNotar was a certificate authority around a decade and a bit ago that got hacked. It's one of many, but it was a very famous one. So why do we have decentralization? Why do we have all these other things to do with certificate signatures, etc.? It's very simple. Security. It's not a political statement. It's not we're decentralized for the sake of it. It is if we have multiple systems all running different operating systems, different things, etc., it becomes more difficult to attack. And if all of those machines need to be set up together, then we push everything to the edge where it can be secured. So why decentralization? What is it? The concept at the moment is completely wrong, where we sit there with Ethereum and everyone runs everything. Well, you don't decentralize something by everything running on every device. You decentralize by having individuals run what they need to run. So the edge of the network is important. Why? Because this is the individuals and their own system. It doesn't matter what you're talking about on anything, whether it's Bitcoin or something else. The edge of the network is where the users operate. So when we're talking about a peer-to-peer system, we're talking about Alice and Bob, for instance, giving their money between each other, communicating directly, not going through a series of nodes, not talking by going to a network and acting as intermediaries, but rather direct low-cost transactions, direct interactions. And the primary purpose of all this is to be able to handle high-speed, high-volume micropayments. That's the one thing that didn't ever exist. Bitcoin's not the first decentralized cryptocurrency. In fact, it's not even the 30th. It's not the 30th even of decentralized proof-of-work systems. There are many people who are a little bit disingenuous because, as an example, Zuku, who basically comes out saying all these things, was behind a project called Mojo Nation, which had a form of crypto credits in it as well. And that was a proof-of-work decentralized cryptocurrency from 2001. So thinking that this is new because it's a cryptocurrency is wrong. The difference in Bitcoin, it's not encrypted, it's completely traceable. There's no way of removing the tracing, despite what people are trying to do with Lightning. And those edges there, Alice and Bob, are where you give money between each other. They're the basic communication path that should occur in Bitcoin. If you're looking at this, then what you're seeing is individuals communicating. How do you maintain privacy? Well, every time you transact, you have a new key. If I'm dealing with someone, I don't go out there and have an address that is well known. Every single time I transact should be a different key. If you're not doing that, then you're not actually doing the privacy model of how Bitcoin was designed, and you don't have privacy. How do you know Bitcoin's private? Well, if you try and figure out every key that changes every time a transaction occurs, you're going to find really difficult sort of communication paths to analyze. And all of this, oh, well, you can tell. Well, no, actually, you can't. So as they communicate, Bob cares about getting his money. So Bob wants to make sure it gets sent to the network. Bob, not Alice, basically should be the one registering this. And if we think about Bitcoin as a form of negotiable instrument, a digital one, then what we're really doing is putting this basically on the network where it gets registered and everyone can see which transaction happened first. So the purpose of nodes isn't decentralization itself. It is a decentralized set of servers that broadcast any spends so that double spends can be detected instantly without the need for internet intermediaries, which is very different from trusted parties. So unfortunately, people have misread the white paper many times, and they take trusted third parties and trusted parties and conglomerate these two terms. They're very different. A trusted third party is a term of art in law for an internet payment intermediary. An internet payment intermediary is not every trusted party that may exist. The first section in the introduction of the white paper notes that there is no method for removing trusted parties or trust. Bitcoin doesn't solve that. It was never intended to. But what it does do is it takes things like certificates and makes them secure. If, for instance, you have a PKI, a public key infrastructure, you can basically now start trusting it. In the past, you haven't been able to. The reason being, you don't know when the certificates change. EHjYxtNuKaI was compromised at least 5 years prior to when people found out the compromise. In that time frame, over 200 government departments around the world were compromised, including military, including the South Korean government, including the NSA, including the CIA, including Google. The signing certificates for Microsoft were compromised, which means every single machine running Windows globally was potentially compromised, and not a single person would ever tell. So when we're looking at these things, we can look at how we have things like Hyperledger and this private idea of a blockchain. There's no such thing. The whole security model of Bitcoin is not about proof of work or proof of stake or any other thing. It is the public dissemination of the hash header. The more people have the hash header, the block header, the more secure the network is. That's it. If 5 billion people run it, it is practically unimpeachably secure. If 5 people run it, if a small company runs it publicly, privately, I should say, it is utterly insecure. The security model of EHjYxtNuKaI was one of the best in the world. All the physical security, all the other controls, and yet they got compromised. They got compromised, leading to the execution of several people in Iran because they were using Gmail and other things, and the government watched. It led to the compromise of several operations in Afghanistan because US military servers were compromised. It led to information being disseminated from South Korea to the North Korean government. That's the level of what we're talking about when we talk about PKI infrastructure. Everything on the internet relies on it. Every single thing. Every time you have a server certificate, you trust one of these companies. And none of them are secure. We're still talking about the same problem, even though we are more than a decade away. And Hyperledger, for instance, is the same problem. Right now, because of IBM deals, every single root certificate is owned by the Chinese government. There's a reason. The only way they could get it tested. So you can say, oh no, we're going to implement it differently. No, you can't. So peer-to-peer exchanges, other such things on Bitcoin, require the correct implementation of something that is publicly announced. And when you're looking at certificates, if you're thinking about the security model of this, the only way you secure something like EHjYxtNuKaI correctly is every single person on Earth sees every single change. The way that you would have all of this on a blockchain is, rather than having certificates sitting on a server and no one knowing what they are, is you would have them published, time-based. So every change is recorded. Every file path change is recorded. Every update to the system is recorded publicly. Then nobody can get away with anything. The reason that the US government brought in Sarbanes-Oxley, basically because of a whole lot of scandals involving companies who had multiple sets of books, Enron, WorldCom, and others. If you have private information where no one can tell what's being updated or not, you really don't know whether things are being updated. So in each of these instances, and then later in Madoff, you had unimpeachably immutable logs. WorldCom, etc., all had logs that provably don't change on all of their accounting. The problem is they all had multiple sets of books. So the only way you stop this is, before anyone writes a single entry, you have a single provable path, traceable, followable, known by the world, such as a company certificate that everyone knows, and you publish that so that no man in the middle can happen, no change can happen without everyone in the world knowing. Once you've done that, and you have a corporate certificate that is completely known, then every single change, every compromise, every other alteration will be known. And by doing that, then the communication doesn't require someone in the middle to validate. It requires the individual parties. It requires that they exchange keys, they update, and they engage personally. So the model that everyone talks about with cryptocurrency is absolutely wrong. The model there is not what it should have been. The reason that I had IP to IP transactions built into the first version of Bitcoin in 2009 was so that people could directly communicate. So that not using addresses, as everyone seems to think, but I connect to your IP address, and with you, I negotiate a new key every time I communicate. That key, of course, doesn't need to actually link to anything that people think is something strange or alternative, man-in-the-middle type attacking, because I can have an identity key from someone like Bob. I can have certificates. And then I get a digital signature. Without that in advance, you don't have a digital signature. You can't sign after the fact. The only way that these two negotiate is they already have some way of telling who they are. So Alice and Bob can negotiate, do a direct exchange, validate who they are, exchange new keys, then do their exchange, verify on the network, and once they have done this, now they have a direct path with an indexed transaction they know is not double spent, because the only part of any transaction on Bitcoin that is not able to be validated without going to the network is, has it been double spent and accepted by the network? Home nodes do nothing. There's a simple reason, they don't write anything to the network. So when you want to transfer the next path, you don't need to pull anything from the network. The answer is simple. Bob hands all the details that he had from Alice to Claire, or Clara. When he does this, of course, he can show where his transaction was accepted on the network, where it's indexed. He can show he got it from Alice. And Clara can now directly communicate back to Bob that she can validate the entire path and that she's never seen a double spend. And that's the secret of SPV. It's very simple. Bob holds the transaction he got from Alice. He hands that to Clara, not the network. He doesn't need to check anything on the nodes at all. And this enables scaling. Why? Because we push things to the edge. When we have it on the edge, no processing happens at all on the blockchain network. The only processing is that transaction has not been double spent, it's being indexed. If there's complex communications, complex updates, CryptoKitties, whatever you want to put on, they happen at the edge nodes where they should be. Alice and Bob negotiate as much as they want. They can go back and forwards with communications, they can update, send invoices, they can basically negotiate, have peer-to-peer channels, and correct all the stuff, which is part of commerce. All of this, people will know who I am. It's not private. Well, really? If you're going to Amazon, is it ever private? And there's a reason for me saying this, because we're not talking about people randomly buying baggies and having them dropped off at the park bench behind the third tree. We're talking about real-world commerce. And in real-world commerce, these guys know each other, always. Privacy is whether the rest of the world knows you. And if you have a new key, how does anyone know you? You don't. This can happen everywhere simultaneously. So when we're talking about commerce, we're not talking about everyone validating everyone else's transaction. We're talking about all of these things happen independently, outside of each other, so that Clara has no idea what Bob or Alice or anyone else is doing. That's how we make a scaled private network. So this whole concept that we have, Ethereum, Solana, BTC, I'm sorry, they're not peer-to-peer, and they're not following any of the protocols set in the white paper. So basically the whole structure of how they're meant to work there, all this sending a transaction in, waiting for it, and then hoping to find something is a horrible model. If you start thinking about it from a computer science point of view, the system is not using peer-to-peer to isolate individual things at the edges, but is rather replicating all the transactions multiple times so that we run it many times, which is, of course, the problem with things like Ethereum. They will never scale beyond the smallest machine on the network. And if the smallest machine on the network defines what something can run, it's never going to run much. So when we have to put it into a network and then dig it out, we're going to argue small block sizes. Very simply, the reason is, if we have to do a search problem trying to find somewhere on the network, the smaller the system is, the faster it is. Alternatively, if we have all of this stuff set up so that we just have block headers, and the communication is the exchange of information between the individuals who are engaged in trade, then very simply, the update is instant. The scaling is automatic. When we're talking about how many transactions we can do, it's unlimited. And the reason is, all we need to do is look at a hash header. That hash header can be automatically indexed, not sorted, directly, binary numbers directly sorted and inserted. It's an O to the N function. It's very quick. And the scaling on existing hardware is billions right now. So what we're talking about is the ability not to have blockchain scale to thousands of transactions that people talk about. We can already do hundreds of thousands of transactions, and next year we'll be doing millions. The scaling capability is billions, if not trillions, of transactions a second. When doing that, we're talking about fees of under 1,000th of a second. Thousands of a cent, sorry. So what we're talking about here is basically everything occurring globally on any system, including IoT, potentially by the year 2030, 100 billion machines, talking as much as possible at a rate that no one cares about. This allows then for the building of overlay networks. When we're talking about how we scale Bitcoin, we don't put everything on it. We don't put everything directly in there like the Ethereum model. What we do is we ensure that the integrity and security, the authenticity of data is protected. And then we build other systems around it. Other systems as peer-to-peer models where individuals engage actively on the edges of the network. This forms a near-complete graph, or fairly much a complete graph in the middle of the network, with external connections allowing the isolation of different aspects of the network so that people can directly trade, interact, send information very quickly. And really, when you're talking about all this, the simple answer is it isn't about having cryptocurrency for the sake of that. It is having a network protocol so that we can actually send and receive transactions. Some of those will be cash. Some of those will be authentication messages to servers. But the only thing that we need to worry about, in the same way that in the 90s we worried about a network war, where we had many different networks, including IPX with Novell, we had DECnet, Banyan, IBM's bastardized thing. All of these ran together. Only one survives. There's only one internet. There's a reason for that. Who wants to pay for the extra cost of having protocol gateways? Who wants to have intranets? In the 90s, IBM brought out intranets, and everyone had to have an intranet because, well, you don't want to connect directly to the internet, and everyone wants to have their own. Guess what? None of them matter anymore. There's one internet. In the future, there'll be one blockchain. And the only way that will happen is scaling to billions and eventually hundreds of billions of transactions a second and making it cheaper than anything ever. And at 1,000th of a cent, which is what I'm aiming for, it's cheaper than any transaction ever sent for any financial system, any logistics system, anything else. Amazon are more expensive, AWS more expensive, IBM are over 100 times more expensive, Microsoft are close to 1,000 times more expensive. So my answer is very simple. Next year, we're going to make people understand that scale works. The minimum block size will be how we define the block size of a network and how many transactions it does. And my aim is to get to millions, and basically, if that means giving them away free, so be it. It's our money. If we want to give things free, it's our choice. So have a nice day.
I have two questions. If this is peer-to-peer communication, telephone, everything, and if I am in charge of the security in the country, and if I want to follow those so-called terrorists or human traffickers and they communicate with each other, how can I follow them?
Everything has traceability.
That's number one question. And the other thing is, for example, if I have to pay my rent to my landlord, in this country, I have to do it through the bank so that the government follows and government wants to make sure that he also pays the tax. So if I pay my rent to my landlord through this peer-to-peer, Bitcoin and everything, so how can the government follow that transaction and he's going to pay the tax? And plus, I don't want to mean that the money laundering and everything. So, I mean, as the government official, whoever you want to convince in this country, security comes first. And you have to convince them that you will be able to follow those terrorists or whatever you mean. Because we experienced something, I hope you won't ever experience again, July 15, 2016. And we were able to follow those guys because of the bylaw and everything. So these are my questions.
This is very
Thank you very much.
Every single transaction on Bitcoin is completely traceable from source to destination over the entire life of the system. If Bitcoin survives 1,000 years, the traceability of everything will be there 1,000 years. So when you're looking at where things came from, then every transaction is completely end-to-end traceable. Now, that doesn't mean that it makes it easy for government. You can't do the NSA monitoring system. What you can do is human, typical old-fashioned human intelligence. When you find someone involved in anything, then you basically do the normal policing where you actually go back to them and you now have evidence of everyone else involved, and you follow the next and the next and the next. Now, that's different to the NSA model where we just watch everything going around the world, but it's the way things used to be. And I much prefer UMINT than signals intelligence. I prefer human involvement in making decisions and tracing by actually interviewing people and following things up. So how do you do this? Well, find out and make a real case and follow it through, trace each person, provably show who was involved, and demonstrate that way. The next question is, well, the legislation over here doesn't require that you use a bank. It requires that you use something that is registered so that the government can trace the payment and accept the money. There's nothing stopping someone creating a Bitcoin application, wallet, etc., that doesn't automatically build in the payment of both tax and recording receipts, etc. For instance, a central bank digital currency could be built within script, enabling the Turkish government to instantly have a transaction record, private traceable information, and tax records. Those tax records would be not only recording the tax, but the payment could be instantaneous. Right now, when you're talking about goods and services tax, VAT, what happens is the money goes to the recipient, who has to then every 3, 6, 12 months give it back to the government. I think it would be far more efficient if a transaction system was built so that the payment was made directly to the government. That would be on each payment invoice, and the government could audit that at any time.
Just to answer the first question about peer-to-peer communication. So you should know that the darknet is used by these criminals. And it takes about 2 to 3 years, even for the CIA or NSA, to find these guys. You know, remember the Silk Road thing. So they already know how to conceal their IP addresses using the onion routing protocol. So the purpose of doing peer-to-peer is you want to protect people, not to leave them as prey by the hackers and so on and so forth, because that's really illegal. You cannot leave people to be hacked. That should be a policy of the government, and give them the chance to protect themselves by talking to each other. And the governments, they should find far better means, you know, to get these, you know, 1-2% criminals and so on and so forth. They should use better means. They should not use, basically block everyone else, you know, to catch 1 or 2. They will never catch them anyway. So it's better to protect your own people. And this is going to be bigger and bigger in the future. We see that now with the wave, you know, of fake news and trolling. It's just a nightmare. So you have to protect your citizens, okay?
Yeah, but in the United States, you cannot make the backdoor available to the US officers, you cannot sell any product.
No, well, yeah, that's another issue. So you're jumping to a bigger topic.
Who said you needed the US to code things for your country?
Yeah.
I mean, my recommendation would be don't use Silicon Valley and involve your own people, have your own government code its own central bank currency based on technology they can audit, and decide that you don't need to have the Americans tell you how to run your own country.
So yeah, the backdoor thing, that's what I was explaining about data sovereignty. So if you have a data sovereignty policy, then basically all the data has to be archived in the country, not outside. Okay? Otherwise, you fall under the Cloud Act. And the Cloud Act forces all US companies to open any database from around the world to them. So this is where the European Commission is pushing this GaiaX project, which is now adopted even by South Korea and Japan, and also China are also looking into it, to have their own cloud services to be saved in the country, and no data is going to quit the country. That's the only purpose, that's the only way to do it.
There are companies, Turkish companies, providing the cloud service in this country.
Yeah, that's the way to do it. That's the way to do it.
Okay, thank you. Any more questions? Yeah.
My name is Gültekin Günal. Now I just wonder in the blockchain technology, you know, all transactions has to have a rule, even between peer-to-peer, and also the transaction based on some reason, as rental contracts, or as Professor Latif says, peer-to-peer, the food coming from the field to the market, you have to follow up the workflow. Who done what? So in that simple way, if such rules not defined in it, how it will mean? Okay, one coin went from one place to another place, but it's not solving the real meaning of the need of the life, you see, because state or some authority putting such rules, even in the US or in Turkey, wherever we live. All flow has to be some rules and must be traceable. So because of the smart contracts concept, someone in it, so it's will be better if you put some more view on this concept. It will be more meaningful, I think. My question is that one. Thank you very much.
The first thing I'll say is there's no such thing as smart contracts. There are automated EDI or electronic data interchange-based systems. Smart contracts is a terrible term used by people who don't understand anything about law or technology. I'm going to say that very simply because a contract is always exclusively a deal between people. There can be an artificial person under law, such as a company, but it's still between people. So if two machines negotiate, well, that doesn't exist. There's no such thing as AI, not really. There's no artificial person in AI. There are only people acting behind an algorithm. So you're talking about rules. The Bitcoin programming language in each script is based on Forth, and it's quite extensive. There's practically anything you can do depending on the cost of what it takes to process is really the determinant, but any of those rules you're talking about you can put in. You can have identity-based information, you can have validation for input, you can have auditing requirements, you can have all sorts of things. The extensibility of the language means the rules are really determining what happens between the two end parties. So if you have two people in a country and the rules of the country say this is how it must occur, then it can be built that way. A wallet can be constructed that when I give you a transaction, you don't just give me a key address. What you give me is a complex template stating all of the requirements I need to feed to you. That can be in XBRL, Extensible Business Programming Language, and that can easily fit into existing databases and have identity information the same as we have in X509. It can integrate the accounting information that is incorporated into XBRL. For those who don't know, XBRL is an extension of XML for accounting and other systems. That will allow you to have accounting fields, data fields, logistics fields, etc. So the rules are really up to you. Machines don't negotiate, people do. So as complex as you want the contract to be is what you can make it. How effective it will depend on you, your lawyers, and everyone else implementing the thing, as always.
Why do you think that blockchain technology and this finance thing is not being integrated to the financial model of the current world? You know, financial institutions and the government does not accept it. And do you know why is it so? And when it will be possible that governments will accept such technology and regulate it in some way so that we can use it?
In 1996, the UNICITRAL model rules for digital signatures and electronic commerce were both implemented. These have been implemented in the European Union in the same year and under the UNICITRAL provisions. These were implemented in Turkey in '98. These are implemented in the US, UK, India only recently. Not quite sure why they're a bit slow on those sort of rules. Pakistan, even Russia, most of the African countries. So those rules existed before Bitcoin. Bitcoin was always regulated. Now, why haven't they been implemented? It's very simple. Scale. People talk about, oh, governments are testing Ethereum. No one's seriously testing Ethereum. No one's testing anything that doesn't scale to the required level. Everyone's abandoning Hyperledger because it doesn't scale. By scale, I mean if from a government point of view, for a basic blockchain implementation, you're not hitting 100,000 transactions a second for that government, you're useless. So the scale question has been it the whole time. The reason I'm talking about getting to billions of transactions a second is very simple. No government will ever think of using a blockchain until it does millions of transactions a second. And you can have all these arguments otherwise, but the reality is you have to handle peak. And it's not even the average transactions a day, it's peak. If you can't handle the volume at the worst time of the day, at the worst year, and everyone has to stop trading, well, that country stops trading. So you can't go, oh, well, too many people are buying and selling things today. Please don't buy something until tomorrow. I mean, worked in Russia, but we all saw what happened there. So the reality is scale and cost. If it's more expensive, it won't be used. And right now, the cost of doing some of these transactions is way cheaper than things like Ethereum. The cost of doing certificate-based exchanges, etc., is in the order of 20 to 30 cents. So governments are going to use 20 to 30 cents until something scales and is cheaper. So my aim is very simple. Under 1,000th of a cent, billions of transactions. And when that happens, they'll be using it. Why? Because it's cheaper, faster, more secure.
Recently, many bridge projects have been destroyed or theft roads. Bridges has been increasing. Will multi-chain project reduce this? And what do you think about multi-chain projects? Thank you.
I think it's another implementation of things like IBM did in the 1990s. In the 1990s, to be on top of everything, IBM brought out protocol gateways. They promoted the idea of your machine can connect IPX to IP. It was the daftest thing ever created. It adds cost, it adds instability, and it adds an ability to game the system. So the question is, well, if I have a ledger equivalent to a paper double-entry book where I can't change things, but now I can have as many alternative versions of that as I want, will that be secure? So with multi-chain, well, instead of having one system, I can flip around to as many as I want. So I've mentioned this many times. Bernie Madoff had 7 sets of books that are known. He got away with all these frauds because he had one for some SEC, and he had one for some of his major sort of suppliers, and one for investors, and one for showing the public, etc. And nobody thought that, well, maybe we should all compare the same things. So if you have multi-chain, well, you just have multiple copies of everything. How many internets do you have? One. You don't need many. And if you have one copy of a record, why do you need a copy on something else? The argument is purely those things can't scale. So let's horizontally scale by having lots of different ones. Well, that's a failure. So if I don't have a big enough car to put my family in, I don't want to buy 3 minis. It's the same thing. You're welcome.